Related angles. This short video is just going to review some ideas that we've seen in the 5.4 lessons. So I'd like you to, on your calculator, find the value of these four values. Tan of 10 degrees, tan of 170 degrees, tan of 190 degrees, and tan of 350 degrees. So take a moment on your calculator and write down, let's say to 4 decimal places, the values of these 4 expressions. And I'll do the same. Pause the video here for a moment. Okay, so here are my results. So my first question to you is, would you be able to explain to somebody why it's not surprising that for these 4 angles, we got the same trig ratio value, except these 2 were negative and these 2 were positive? Hopefully what you would explain is that these 4 angles are related angles. What makes them related is that for these angles, they have the same related acute angle. And remember, a related acute angle is what we refer to as beta. So let's see what we mean. So if I were to draw on the Cartesian plane, first let's label it 0 degrees, 90, 180, 270, 360. Let's draw what 10 degrees would look like. 10 degrees would look like this. Let's draw what 170 degrees would look like. 170 degrees would be 10 degrees short of reaching 180. So if this is 170 degrees and it's 10 degrees short of reaching 180, then how big is beta? 10 degrees, right? Because that would be 170 is 10 degrees short of reaching 180. Let's draw the next one. 190, that's 10 degrees past 180. So 190 is 10 degrees past 180. So this beta is the same. What about 350? 350 is 10 degrees short of reaching 360. So 350 is 10 degrees short of reaching 360. So it has the same size beta. So these 4 angles are referred to as related angles because they have the same related acute angle, which means that if I were to take each of these terminal arms and turn them into a little reference triangle, these reference triangles would all be similar triangles. They all have a 90-degree angle and they all have a 10-degree angle, which means automatically that they all have all 3 angles the same. And that means that the ratio between the opposite and adjacent side, which is what we look at for tan, they're all proportional to each other. But let's see. What about the positive and the negative? Well, if we add the letters of the cast rule, the tan in quadrants 1 and 3 are positive. Let's see. The angle in quadrant 1 and 3, its tan came out positive. What about quadrants 2 and 4? Tan is negative there. The tan values came out negative there. And so see, this is why if you were looking for an angle on your calculator, let's say you did tan inverse of 0.1763, your calculator would tell you 10 degrees. But let's say you were looking for an answer in quadrant 3, then you'd have to make sense of that answer and realize that, okay, I need the related angle that's in the quadrant that I want. Remembering that also, sometimes your calculator gives you negative answers. So like if I was working in the negative direction, this would be called negative 10 degrees. This would be called negative 170 degrees, etc. So you have to be super comfortable with understanding why it is that your calculator is just a tool to help you get an answer that might help you get the answer that you're looking for. And it's all through an understanding of related angles and how terminal arms with the same size related acute angle have the same trig ratios in absolute value. The plus or minus comes from the positioning and the cast rule. So just a little exercise there to review that.